SKU is SKU stands for store keeping unit, right? A store keeping unit is like a really long string of numbers and alphabets. Each product, not let's say you have a AA battery, okay, a packaged AA battery of a specific model and a brand and a model. That'll have an SKU, okay? If you take another one of the exact same kind, it'll have the same SKU, right? So those are 100,000 separate products. I'm not talking about like products regardless of the model or brand. 100,000 unique products, and each store has 100,000 of those. And Walmart has 1 million transactions every hour. Okay, so if you think about these numbers, you can't really grasp them. It's very hard to understand. Okay, yes, 1 million is a big number, yeah, but you know that 1 million, I think 1 million seconds is like, 1 million seconds is 11 days. It's a gigantic number, and data science allows you to, when you break those numbers down into visualizations, into when you process them, basically, you can actually kind of perceive that number. Okay. Let's keep. I'm gonna keep throwing numbers at you because numbers are fun. Tesco. Okay, Tesco has 1,800 stores. That's slightly smaller than Walmart. They have 35 million club card customers. Okay, and over 1 billion items home delivered annually. Okay, that a million's already a huge number. This is a billion. And Airtel, let's talk about Airtel. Airtel has 261 million subscribers. They have 8 billion calls every single day and hundreds of different call plans. Okay, so these are numbers, as I said again, it's data is everywhere. It's so abundant. We can have, so each of these 8 billion calls, they might have dozens of data. You can have the name, the address, the phone number, what kind of plan they took, and yeah, it's overwhelming, and data science allows us to make sense of it all. Right. So complicated things with data science. There's some of the techniques involved can be a little complicated, but if you break down the reason why computer scientists, data scientists exist, their sole job, the purpose is to answer questions based on data. If you do that, you're a data scientist. Okay, there you can do it however you want. Let me tell you guys a little example of a data scientist. Imagine a 10-year-old, okay, playing hide and seek with their friends. Okay, so they have 4 or 5 friends, and so the 10-year-old, let's call him Mark. Mark has to count to let's say 20. Okay, as a 10-year-old, counting to 20 is already quite hard. So you go, at least it was for me, where you go next to a tree, you count to 20, and then you turn around, all your friends are gone, right? And then you start thinking to yourself, so the problem statement, what's the problem statement? Where are my friends, right? You're playing hide and seek, that's the problem statement. So now you have, so what do you have to solve this problem? What resources do you have? Well, you have a database of the 100 other times that you've played hide and seek with your friends, right? In the same playground with the same friends, right? The weather might change; it might be a little different. There are certain things that may be different, but there are a lot of consistency. There's a lot of consistency with the data. So now you recall, okay, so Greg, right? I'm just making up names here. So Greg is kind of a small guy, right? He's a little short, he's a little skinny. He can probably he usually goes under the bushes, right? Most of the time he goes under the bushes, but sometimes he's gonna hide behind his dad's car, right? So what do? You assume what's most likely. That's data cleaning, all right? As you would do in Python. And then you probably are gonna go and look under the bushes, and boom, you found him, right? And you can do that with your other friends. So we humans are already intuitively data scientists. Okay, it's a very intuitive process of finding these solving these problems using data. We've been doing it intuitively for years, ever since we were kids. And the only difference with being a data scientist is the technique that we use. You can't expect a 10-year-old to pick up Python and plot out a chart of the most, like, create a machine learning algorithm to find his friends for him. But yeah, the only things that change is the technique. So that's why data science is hard. But if you take that out of the equation, it's very intuitive. It's just using data to solve problems. All right. Are there any questions or anything that you guys want to add on? Just feel free to, because I feel like I'm the only one talking. Anything at all?
Sorry, like nothing really comes to mind at this stage.
All right. No worries, no worries. Okay. Okay. Let's. Okay, awesome. So, Bill asks, well, how qualified shall a person be to handle data science? Actually, right. I think if you guys are asking about entry level job in data science, they don't expect much from you. They expect basic Python and SQL. These are just two programming languages. If you know these two, most of the frameworks that we use, they heavily rely on these two, right? I'll give you a bit of background on my experience with data science. So before my uni started, so I graduated in September, and 3 years before that, I did an internship with Lenovo, and I was the assistant data analyst there. And I had to deal with ClickSense. Have you guys heard of ClickSense? It's a business intelligence tool. You guys must have heard of Power BI, Tableau. Yeah, ClickSense is another one. Okay, and it has its own little scripting language. But there was also, yeah, you've heard of Power BI. It has its own scripting language, but it also uses SQL. So I would query data from the data warehouse. I'll clean it up using SQL, and then I will, use ClickSense, the scripting language in ClickSense, to make visualizations. But yeah, as I said, that scripting language was only specific for Tableau. I think if you use Power BI, it's going to be different. If you use Click, yeah, the scripting languages was specific to ClickSense. I don't know why I said Tableau. And Tableau is going to have its own scripting language and so on. So that's why I said the technology. I think, to answer your question a little better, a mark of a good data scientist is being able to adapt to all these different technologies, because they're going to change almost every month. right? There's always going to be a better system to use. Okay. Okay. Yeah. Let's move on to a few more numbers. Just a few more because numbers are cool. 1 million gigabytes of data is processed by Google every hour. All right. And 30 billion pieces of content shared is shared on Facebook every month. And those numbers are big, but imagine this: 2.8 trillion rows of data is in Sprint's database. Do you guys know about Sprint? It's a telecommunications company. And yeah, they have 2.8 trillion rows of data. And Google's, this one, I don't even understand this. We can pretend to understand these numbers, but we really can't grasp them. Google's database has 300 trillion entries, which is mind-boggling. So these big numbers, that's where big data comes in. Big data is the art of dealing with these huge numbers, processing them, optimizing systems to handle them. So that's big data. Okay. So are there any questions? No, I'm just spitting out like facts. Just to give you guys a context of how the industry that we're dealing with. So did you guys know that 90% of the world's data has been generated in the last 2 years? Which is incredible because that's how fast data changes. If you want to, that's how fast trends change, right? 90% of the world's data, yeah, has been generated in the last 2 years. Because if you want to predict something this year, you can't go too far back because the trends back then aren't going to be the same as the trends, just a couple of years into the future, in the past. All right, so let's talk about some of the applications. Okay, so I've spoken about the these business problems, right? That we can solve. So what are these problems in the real world? Like, let's say you get a job when you get a job in data science, what are these problems that we'll face, right? So let's look at something fun like football, right? Who here watches football? No one? Am I the only one who watches football? Okay, a bit. That's good enough. I'll take that as a win. I see. Okay. Yeah, so football there's this whole branch of data this whole branch of applications for data analysis, which is sports analytics. Football the football clubs use data analytics to identify players who are valuable but not expensive, right? So you can get like the stats, like how many passes they completed, how many dribbles they completed, how many goals they scored per game, and each club will probably have their own data science team trying to get the most valuable players, the most promising players, with the lowest price. Let's say there's a 17-year-old, right? Their price aren't his or her price isn't going to be that high, but if they are showing promise, then the system will probably flag them, and then they can either the club can purchase them. They also use predictive models predictive model is a model. It's a type of model in machine learning to prevent player injuries, right? So they can look at their track records for the past few games, and then decide, okay, is this player going to get injured? Because the last time he played, 4 or 5 games in a row, he pulled a muscle. And analytics, they use analytics to evaluate players' performance and team strategies, right? And they also identify most valuable supporters and offer them benefits to help build loyalty, right? So this has to do with more of marketing. Like if I know Malaysia, I know football is quite big in Malaysia, so they're probably going to market heavier in this region than other regions, right? So let's look at let's say credit card companies. How some of the problems that they may face is, who should I offer my credit cards to, right? There's some people who may get offered a credit card based on the loans that they took, based on how the income flow, and yeah, this is actually a pretty big problem, because it can either save or um, companies can lose a lot of money. Like credit card companies can lose a lot of money from this. How do I decide on a credit limit for each customer? Obviously, this is by the bank. How do I fix the interest rate? How do I identify fraud, which is huge? It's massive. Jeffrey, you're into cybersecurity, right? This is kind of where data science and cybersecurity may like overlap. You may have to be a expert at both to identifying fraud. How do I predict bankruptcy? There are so many, right? And all of these has the potential of being answered in full by data. Okay, let's talk about retailers, right? So Tesco or Walmart. How do I stock the products in order to maximize my profitability? Okay. What does that mean? I think they're talking about um, where to place the products. Let me tell you a funny story. I was talking to my manager in Lenovo, and at his previous job, he was in charge of coming up with a machine learning algorithm, a predictive model he was working for a retail store in India. Um, it was a pretty big retail store, and he was in charge of coming up with the predictive model to identify which um, aisles, okay, to place which products, okay. And for example, it makes sense to put the fruits next to the vegetables, right? Or put all the vegan products in one place. You don't want to have them like running back and forth, like putting one vegan product here and then one somewhere else. And he told me the story. So when he ran that machine learning, um, he trained it for like a couple of hours, and then when he saw the results, it asked one of the results was they have to put baby products next to alcohol. um, and I guess it's because when you have a child, you're probably um, stressed out and you're probably going to drink. Um, so yeah, it may not always be the best idea to use data science for problems like that, but at least you can use it for the memes. So okay, that's one. That's a tangent. Another problem that retailers might face is, how do I market to my customers to maximize my appeal, right? How do I price new and existing products in my store? How do I design promotion strategies to maximize customer benefit? The uh, I can keep going. I can go on and on. But yeah, so these are the problems that you would probably face when you when you start working in a company as a data scientist, right? But this is all boring, right? We don't want to worry about this stuff now. I want to show you guys some of the projects, like some of the cool. Um, as I said earlier, there's so much you can do with so little in data science. And let me show you some of the projects that I found online. I'm sure you can find many more, but uh, let me okay. Let me share my screen. All right, cool. Can everyone see my screen? Okay, cool. All right. So this is a really cool website that I came across in uni. It's basically I'll send you guys a link. You should definitely just scroll through it while I'm explaining it. You know, it's very cool. So the World Atlas of Language Structures, or WALS, is a large database of structural, phonological, grammatical, lexical properties of languages gathered from descriptive materials such as reference grammars by a team of 55 authors. Right. So it's a database of languages and where they come from, and how they migrated. And it blows my mind how cool this is. Probably this is probably a single CSV file, right? It or two maybe, and they made something so beautiful with it. So if we just hover over these different, I think, most spoken 10 language families, you can see which region on the map they most likely originated from. Um, so Indo-European, it's really cool. Um, and then I think down here there it's kind of small, but I make it bigger maybe. Number of speakers: 86% of world population speaks one of the 1.322 languages belonging to the 10 most spoken families. Right, there's a bunch of stuff that you guys can see, but I think my favorite one is, I think it's down here. Yeah, look at this. Check this out. So language loanwords, right? This is basically a map of how language um, got migrated. As people moved, they brought the language with them. So let's click on English. You can see the reach that English has. It's everywhere. Spanish they mostly went to South America. Some went to Japan. Really? Oh, this is probably because I see a line to Indonesia, probably because of colonization, right? Mandarin, and I just find this so cool. And what blows my mind isn't the fact that someone made this; it's the fact that someone made this out of so little. This is a simple database that they had to clean up, and they had to extract all this data from, right? So yeah, you can check this out. There's some stuff that I scrolled through. I actually don't know what they're trying to say here. I don't understand this graph. Number of speakers: 86% of world population speaks one of the 1.322 languages belonging to the 10 most spoken languages. I don't understand it, but it's really cool. Yeah, this is one of them. The next one is this. I sent this link over as well. Yeah, so this is what machine learning is, right? You can they probably had data from um 1950 till I don't know when was this made, 2014 or something. And they used that data on a machine learning algorithm to predict how um, the gender um, like the how gender demographic is going to change, gender composition is going to change over the decades or every 5 years, right? So 1990, we have all this data. It's not very impressive, but once it goes over, like let's say 2020, right? All this is based on is using machine learning. And I read somewhere that they also take healthcare into account. Um, it's very, very impressive. See, yeah. And the last one is my favorite, so I saved it uh, for the last. This one we can spend hours on it. So this is Selfie City. Selfie City investigates selfies using a mix of theoretic, artistic, and quantitative methods. We present our findings from the demographics of people taking selfies, their poses and expressions. Rich media visualizations assemble thousands of photos to reveal interesting patterns. The interactive selfie exploratory, this is it, allows you to navigate the whole set of 3,200 photos. So what they did, they basically have this giant data set of selfies, and they used machine learning to identify if crazy things. Like I'll show you, but um, they identified their age, the estimated age. So as you go down this line here. So the bottom, I think the bottom is male, the top is female from Bangkok, you know. And the higher you go, the more left you go, the more their age, the older the people in the photos are, right? This is people from Berlin, this is from Moscow, New York, Sao Paulo. And it also has facial recognition, so you can it also identified if someone is frowning. So let's look at a very sad guy somewhere here. Look at him, he's so sad. And if let's look for a happy girl. There, look. That's so cool. The fact that the system actually picked it up. Oh, this person, I mean, it's not perfect. For some reason, it thinks that this person is happy, which they're not. They look very sad to me. Um, well, a lot of people are happy in Sao Paulo. Yeah, but yeah, so uh, this is the so they made this interface where you can choose like various things. All you have to do is drag, and it'll show you all the happy people. Oh, I mean, not happy people. This is sad. I guess this side is happy. Yeah, right. And it also it'll the system also picked up if they're either looking right, okay, or looking left, which is so cool. And I'm coming back to the point of how data is oil, right? You're only able to do this because you have such a large number of selfies. You have a lot of data to analyze, and that's what makes data science cool. Because although you have a lot of one thing, um, it can be as something as simple as a selfie, but you can do amazing things like this. Like the oldest or like older people probably looks for wrinkles, right? And I guess that's quite accurate. Yeah, these are kids, and then probably middle-aged, right? And it can also do it by gender, right? And if they're either looking up or down, or if they're tilting. Oh, okay. At this point, I'm just playing around with this. This is so cool. If they're looking straight at the camera, if they're wearing glasses or not. Um, I mean, there are some that slip through, but the wonderful thing about machine learning is if you just train this model longer or train it a little smarter, it can solve for these inaccuracies. And if they have the mouth open or closed, right? Yeah. So yeah, as I said, something so interesting and fun to play with, out of something um, so basic, which is just a bunch of selfies. Uh, yeah. So I mean, let me send you. I think I sent this one as well, right? Okay, I did. Yeah. So yeah, that's data science. This is an introduction, just a very quick introduction. Next week we will not next week. I think in my next actually I think it's somewhere in May. We'll actually look at examples, nothing too fancy, just to give you guys a feel for uh, how to actually implement some of these techniques, how it actually looks um, when we solve some of these problems. But yeah, is there any of your thoughts? Would anyone like to share their thoughts or any questions, anything you'd like to ask?
Will you happen to have more stories to share? Actually, your experience at Lenovo is quite interesting.
Oh, okay. So yeah, that was actually my first internship, right? The 3 years, the first internship that I did was before I started uni, but in second year of uni, um, when I during my summer break, I just wanted to chill. I didn't want to do an internship, but my mom applied. She works in Lenovo. I know it's nepotism, but I got the job through her. But the second time I got mom applied without telling me, and then I had to go. But that was very eye-opening because I wasn't the assistant data analyst. I was actually a full stack data analyst. I did everything like from level one to creating visualizations for like upper management. So I would query data from the data warehouse. So a data warehouse, big companies like Lenovo, they have these things called data warehouses where they store millions of millions of gigabytes of data, right? You can imagine how much data Lenovo has. And so I had to query the data, which is a lot harder than it sounds because you have to be very, very precise. Let's say they want someone from upper management wants data from 2015 to 2018. Okay. I have to take data between um, those 2 years. I basically have to be very, very precise. And I made a lot of mistakes, but that's just how you learn. Um, so I query data. Then again, I cleaned it up using SQL, and then use ClickSense to um, make visualizations. And some of them actually got published to upper management. Considering that is by an intern, I was very, very proud of myself. But that kind of like I really got hooked into data science because of that. Um, Before that, I was just doing it because of experience. Like didn't even care, didn't really care about it. But I realized the when when you work with like oil, like that's what data is. It's just a CSV file. It's barely readable. Like all the dates are like in these weird like date formats, and you clean it, you extract the dates from it, you extract the months, the years. I'm just giving an example. And so you have these random regions, and then you um, segregate them into sorry, you have these random countries, then you segregate them into these regions. For like there's um, like the Americas, and then Southeast Asia, and then uh, Europe, Europe and Africa, yeah, and then the Oceania. So when you slowly extract data, it makes it's very, very rewarding, because no one tells you these things. No one tells you, oh, you have to do this, this, this. They're going to say, look, I want a line graph that shows this. The x-axis has to show this. The y-axis has to show this. The rest is up to you. And like that process of slowly making sense of the data, that's what made me fall in love with it. Yeah. And then since you like my stories, for my FYP, I actually I did uh, I did my FYP on analyzing song lyrics using machine learning and AI. So I had this giant database of I think it was 300, more than 300,000 songs, but I think I had to cut it down because some of the lyrics were corrupted. So I think I was left with 180,000 songs, and I fed it into various models that I made, machine learning models, AI models. Um, I just wanted to experiment. Yeah, yeah, machine learning with lyrics. Yeah. Um, I basically wanted to experiment with everything in Python, like because Python is one of the biggest languages that they use in data science. And I just wanted to experiment with all of them. So I just did everything: NLP, natural language processing. I used Doc2Vec, which is I think Doc2Vec is a predictive model. It basically predicts. Let's say you have a PDF file, right, and it's labeled. Okay, it'll if it studies that PDF file, then if you go ask it to predict what that the other PDF file is, it's going to predict that label correctly. So that's Doc2Vec. Um, I made a neural network model to generate song lyrics, which was very hard, very, very, very hard. And it took me a very long time, but it was it was a cool learning process. It wasn't very good, um, but I didn't expect it to be very good. It's like some of the lyrics were a little wonky. Um, uh, but yeah, I just kept tweaking it, and then I ended up getting first class. So yeah. But the main takeaway from that story is, I think if you really want to get into data science or anything in computer science, the biggest um, the most important thing is just learn it yourself. Like if you expect other people to teach you, you're not gonna get far, right? Yeah. Yeah. So that's I wouldn't say a bit about myself, a lot about myself. That's how I fell in love with data science. Is there anything else?
How many permutations do you think it would take for you to write web using your current implementation?
Permit. Wait. Can you repeat that?
You know the song WAP?
Ah.
How
Oh,
long do you think it would take
so
the neural net
so
to
it.
write that?
I think right. So the my system, right? What it did, I trained it to learn all of those songs, like 108. I think my no, not 180K. I had a smaller data set for that because it took me 8 hours to do each genre. Okay, no worries, Jeffrey. Yeah, it took me like 6 8 hours to do one genre. So what I would do is I split all the songs by genre. I would run the neural network on each genre, and I would um, generate a song lyric per genre. So I can't just uh, generate WAP, right? I can generate a song from hip hop or R&B, right? Because I had the genre, but yeah, that's how it worked. But I think yeah, wouldn't I just have to copy paste the lyrics?
I was kind of hoping that you give a joke answer, but it was a pretty informative one.
Yeah. The thing the But then again, like the problem that I had to solve was I I ultimately wanted to get rid of songwriters, right? I wanted to not give them jobs basically. So I want to, let's say okay, Samson, you want to be a country writer, right? You want to write country music, but you're too lazy, right? You can use a neural network to generate a country song, a neural network that has already been like studied 5,000 country songs. It's going to take those patterns, right? So if you use this word, what comes after this? Okay. So it's going to look at those patterns and create a unique song for you. So that was the problem that I was trying to solve. Yeah. I could if I who sang WAP? Cardi B.
Yes, probably.
Yeah, if I probably um analyzed all of Cardi B's songs, right? And if I made enough examples of songs, you might find a song that sounds something like WAP. But the point of it is for it to be unique. You don't want to create, WAP. You want to create a new song.
Overall, I think you'll probably watch Kerry KH. I think he tried the same thing as well.
Carrie KH, is he a YouTuber? How
Yeah, he does mostly machine learning.
do you spell his name?
Kary KH, no spacing.
Oh, oh yeah. I know him. Yeah, I watch him all the time. Yeah, he's very, very, very talented. He builds these models extremely quickly. Yeah, I watch him all the time. Are there any other questions, guys? Anything anyone wants to add on? There's just this like the last few minutes just for us to chat. Yeah, no, if it's fine if there aren't any, then we can end the session. Um, I'm sure some of you have work to do, right? So I'll let you guys get back to it. But yeah, thank you so much for joining. This is awesome. Like this geeking out on something that I'm. Yep. Thank you for joining.
Thank you for your time, Logan.
Yep. Thank you guys for your time too. Thank you. Thank you for joining. Yep. Thanks, Bill. All right, let me stop recording. Bye, guys.